All right, so now let's talk about properties of integrals. Well, so the properties of integrals that I want to mention to you are these. The first one doesn't bear too much comment. If you take the cumulative integral of a sum, you're just going to get the sum of the separate integrals here. And I won't say much about that. That's because sums come out, because the integral is a sum. Incidentally, you know, this strange symbol here, there's actually a reason for it historically. If you go back to old books, you'll see that it actually looks a little bit more like an S. This capital sigma is a sum, S for sum, because everybody in those days knew Latin and Greek. And this one is also an S. But gradually, it was such an important S that they made it bigger. And then they stretched it out and made it a little thinner because it didn't fit into one typesetting space. And so just for typesetting reason, it got stretched and got a little bit skinny. Anyway, so it's really an S. And in fact, in French, they call it sum, even though we call it integral. So it's a sum. All right, so it's consistent with sums in this way. And similarly, we can factor constants out of sums. So if you have an integral like this, the constant factors out. But definitely don't try to get a function out of this. That won't happen. Okay? In other words, C has to be a constant. Doesn't depend on x. All right. The third property, well, what do I want to call the third property here? I have a sort of a preliminary property, yes, here, which is the following, and I'll draw a picture of it. Suppose you have 3 points along the line. So then I'm going to draw a picture of that, and I'm going to use the interpretation above the curve, even though that's not the whole thing. So here's A, here's B, and here's C. And you can see that the area of this piece, of the first 2 pieces here, is, when added together, gives you the area of the whole. And that's the rule that I'd like to tell you. So if you integrate from A to B, and you add to that the integral from B to C, you'll get the integral from A to C. This is going to be just a little preliminary because the rule is a little better than this, but I will explain that in a minute. The fourth rule is a very simple one, which is that the integral from A to A of f of x dx is equal to 0. That you can see very obviously because there's no area, no horizontal movement there. The rectangle is infinitely thin, and there's nothing there. So this is the case. You can also interpret it as f of a minus f of a. So that's also consistent with our interpretation in terms of the fundamental theorem of calculus, and it's perfectly reasonable that this is the case.